Let's take up another numerical which reads as below. 2 stones are thrown up simultaneously from the edge of a cliff 200 meter high with initial speeds 15 meter per second and 30 meter per second. Verify that the graph shown correctly represents the time variation of the relative position of the second stone with respect to the first. Neglect air resistance and assume that the stones do not rebound after hitting the ground. Take G is equal to 10 meter per second square. Give the equations for the linear and the curved parts of the plot. So, well, yes, now you have a problem here on free fall actually. I mean, it's a free fall situation where 2 stones are being thrown up from a cliff which is above the ground of about 200 meter height, right? So the cliff height is 200 meter from the ground, and both the stones are thrown simultaneously with different speeds, right? So they both undergo the same acceleration, that is the acceleration due to gravity in the downward direction. So they have a plot of the relative position of the second stone with respect to the first versus time, right? So you have to verify this particular graph that is given. So x2 minus x1 is the relative position of the second stone with respect to the one, or in other words, it's just the part, it's a plot of part difference between the stones to the time taken for the stones to reach the ground. So you can see from the graph that up to 8 seconds, it's you see that says there's a straight line, and then there is a change in the graph, right? So we have to verify whether the given graph is right, and we have to write down the equations for both the parts of the graph. So let's begin. Now, before I start answering this, we better write down a diagram for the given situation. That will make it more easier to analyze the problem. So here we go. We'll write down the situation given or described in the question. So let me say this is the cliff. Okay, let this be the position of the cliff, and maybe this is the ground level. Okay, so so this is the ground level. Okay, so I take the ground level as 0, obviously, that position, and this is the cliff. Okay, so this is the edge of the cliff edge. A diagram would make it easier to answer. So there are 2 stones that are thrown simultaneously. Let me say this is stone 1. Okay, I denote it by pink color, and then this is stone 2. Both are thrown in the upward direction with different speeds, right? So V0, which is the first stone, was thrown with a speed of 15 meter per second. Similarly, the second one was thrown with a speed of initial velocity of how much? 30 meter per second, right? Now, this is the initial position from where the stone was actually thrown. So I take the initial position as x0, which is also nothing but the height from the ground level. So I call this level as x0 is equal to 200 meter height. So if I call that as x0, let me call this as x, the ground level, which is 0. So the ground is at, so there is a distance of how much? 200 meter, right? Now, both the stones experience acceleration due to gravity in the downward direction, and the acceleration due to gravity is given by minus g. Upon reaching the ground, both the stones come to rest, right? So the first one as well as the second one, so their initial velocities are known. The final velocities for both the stones would be 0 upon reaching the ground. So this is all the information that we have first on hand, and based on this we can use the equations of motion in order to write an equation that connects x naught, v naught and a and time, right? So time is what we have to calculate. So let's first do a numerical. Let's say this is the maximum height reached by different stones. So very obviously, when you look, stone 1 was projected at 15 meter per second, so it would reach a certain height. Stone 2 was projected with a higher speed, so therefore it would obviously go to a greater height because it was thrown with double the speed as the first one. So these are the pictures that you should get in mind before you write down the equations of motion. Also make a note of the point that since it was thrown with a lesser speed, it would reach a lesser height and would hence reach the ground in a lesser time, the stone 1, which was projected at 15 meter per second. Whereas the stone 2, which was projected at 30 meter per second, double the speed of the first one, would reach a greater height compared to the first one, and hence would take a larger time compared to the first one to reach the ground. So you should always remember, when you try to calculate the time taken by each stone 1 and stone 2 to reach the ground, you should end up with an answer where t will have a less value for the first stone compared to the second one, because time taken by stone 1 will be less to reach the ground compared to t2. So t2 would compared to stone 2, because stone 2 would take a larger time to reach the ground because it was projected with a greater initial velocity, and hence it would reach a greater height, right? So if you know this, you can when you get the answers, you can actually verify whether your equations are right or wrong. So let's write the equations of motion for stone 1. Okay, I'll write that down here. Stone 1, let's say I write the equations of motion. So you can use any of the equations of motions that you know. It's better to use an equation of motion that has x, x naught, v naught, t and a. So I will use this equation of motion, which is x is equal to x naught plus v naught into t plus half at square, right? So x we know is 0, that is the position of the ground. So ground is at 0. X naught is the clip distance from the ground, which is 200 meter. V naught is the velocity with which the stone 1 was projected, which is 15. Time is unknown, so I leave it as such. Plus half into acceleration due to gravity in the numerical is given as 10. Since it is in the downward direction, the usual convention we always use for the downward direction is minus. So minus 10 for acceleration and t square. Okay, so I'll further simplify this. This would be 200 plus 15 into t minus 5t square. Okay, now what you can do is you can bring all these on the left hand side. So you see when you bring minus 5t square on the left hand side, it would become plus 5t square. When you bring plus 15t on the left hand side, it would be minus 15t. Similarly, when you bring it on the left hand side, this becomes minus 200 is equal to 0. So here I can take 5 common. When I say you are taking common, that means you are dividing this entire term, which is 5t square, divided by the common term 5. So if 5t square divided by 5 would be 5 and 5 would get cancelled, you would end up with t square. Next you have a minus, you keep minus. 15t divided by 5, so 5 ones are 5 threes are, so you have 3 into t as such. You have a minus, you keep it as such. So 200 divided by 5 will be 40. Now that is what is equal to 0. Now I bring this 5 on the right hand side. So the equation would now be t square minus 3t minus 40 is equal to 0. When it comes on this side, it becomes divided by 5, and 0 divided by anything is 0. So you have an equation for stone 1, right? So I'll write it here. So the equation is t square minus 3t minus 40 is equal to 0. Now this is a quadratic equation. Now when you have a quadratic equation and you have to find out the value of t, what you do is you try to factorize this. So how do you factorize? Let me find the factors for 40. So I'll do the working this side. So 40, if I find the factors, if I divide it by 2, 2 20s are 40, 2 10s are 2 into 5, right? 2 5 times. Now I will have to arrange these 2, 2 and 2 and 5 in such a way such that when I multiply them I should get 40, and when I add them I should get minus 3, right? So what can I do is, see, I'll group these and group these as separate. So I will group these as 2 into 2 into 2 will be 8, and then I have 5. So 8 and 5 are the two factors. So when I multiply 8 into 5, I get 40. Also when I subtract 8 and 5, I get minus 3. Now I need minus 3. So if I want minus 3, 8 should have minus. So minus 8 plus 5 would give me minus 3. So this should be minus 8 into 5 would be minus 40. So my factors are, so minus 3t can be written as minus 8 into t plus 5 into t, right? So minus 8t plus 5t would end up giving you minus 3t. So you can replace minus 3t in this equation by minus 8t plus 5t. As simple as that. That's how you factorize. So minus t square. So in place of 3t, I replace it by minus 8t plus 5t minus 40 is equal to 0. Now you have to take common. So what is common in this? T is common. When I say common, that means you are dividing this term by the common term. T square divided by t would give you t. There is a minus, keep it. 8t divided by t would give you 8. Plus, here I take 5 as common. So 5t divided by t would give you t. You have a minus. 40 by 5 would give you 8. That is equal to 0. Now what is common in these? T minus 8 is common. So let us take t minus 8 common. So if we take t minus 8 common, what remains? T into t minus 8 divided by t minus 8. T minus 8 would get cancelled. You just end up with t. Similarly, you have a plus. You keep it plus. So 5 into t minus t divided by t minus 8. T minus 8 would get cancelled. So you get 5. So these are the factors. So hence you have factorized the given quadratic equation. Now this means you have t values, so 2 values for t, that is t minus 8 is equal to 0 or t plus 5 is equal to 0. So if I bring it on the right hand side, this becomes plus 8. That means t is equal to 8 seconds, or t is equal to, if I bring it on this side, minus 5 seconds. Now time cannot be negative, so this option is ruled out. So what time does the first stone take to reach the ground? The first stone takes 8 seconds to reach the ground. So we have solved first part of the problem. Now I have shown you how to factorize, how to take common terms and all that. So I wouldn't be explaining in so much detail for the second one. We'll use the same method, the same equation, and write an equation for the second one. So I'll do it for stone 2, right? So for stone 2, let's write the equations of motion. So it is x is equal to x naught plus v naught into t plus half at square. X is 0, ground level. X naught is the height of the cliff, the position of the cliff, which is 200 meters above the ground. V naught, it was projected at 30 meters per second, into t plus half into acceleration due to gravity is minus 10 into t square. So we just simplify this. This becomes 200 plus 30t minus 5t square. Now you bring it on this side, so all the signs get reversed. This becomes plus 5t square minus 30t minus 200 is equal to 0. I will take 5 common, so I get t square minus 60 minus 40 is equal to 0. So this would be simply t square minus 60 minus 40 is equal to 0. 0 divided by 5 will be 0. So I have to factorize. So again you take the factors for 40. So 2 20s, 2 10s and 2 5s. I will have to arrange them in such a fashion that when I multiply I should get 40 and when I add them I should get 6. So I will group these, that is 2 into 5 is 10 and 2 into 2 is 4. So I know 10 into 4 is 40. 10 minus 10 plus 6 would be, 10 plus 4 would be minus 6. So minus 10 into 4 is minus 40. So minus 60 can be simply written as minus 10t plus 4t. So these are the factors. So I just write this in place of minus 60. I have minus 10t plus 4t minus 40 is equal to 0. So I take t common here. If I take t common, I get t minus 10 plus 4. If I take common, I get t minus 10. So that's equal to 0. Now if I take t minus 10 common, I'll be left with t plus 4. So there are two values for t again. T is equal to 10 seconds or t is equal to minus 4 seconds. Minus cannot have a negative value, therefore stone 2 takes 10 seconds to reach the ground, right? So this is what we have got. Now let's go to the question what is being asked now that we know the time, and it is very logical in accordance. You remember I told stone 1 would take lesser time compared to stone 2 to reach the ground. So stone 1 reached in about 8 seconds, whereas stone 2 took 10 seconds to reach the ground, since it was projected with a higher speed and hence it reached a greater height. It traveled a larger distance, right? Hence it took a larger time to reach the ground. Now in the question, what do you have? The question says the graph, you have to verify whether the graph shown correctly represents the time variation of the relative position of the second stone with respect to the first, right? So there is a graph of part difference between the stones. So x2 minus x1 is the part difference between the stones. So what does it say? It says at 8 seconds, that is when the stone 1 reached, what happened at 8 seconds? We know at 8 seconds the stone 1 reached the ground, right? So at 8 seconds the position of the second stone, so this means I'll just write it down. At 8 seconds stone 1, what was happening at 8 seconds? Stone 1 had reached the ground. Stone 1 reached the ground, right? So if I take x1 as the position of the stone 1, it had reached the ground and it was 0. Whereas at 8 seconds, stone 2 was still in motion and the separation between stone 1 and stone 2 at 8 seconds separation, that is the path separation, we better call it as the path separation or the distance of separation between stone 1 and stone 2 or stone 2 and stone 1, which is x2 minus x1, was equal to how much? 120 meters, right? So it is 120 meters. That means when stone 1 had already reached ground, stone 1 was still at a height of 120 meters from above the ground. So the difference in distance between stone 1 and stone 2 was 120 meters. I can draw a diagram and show it to you. So we have to verify this claim. So we have to verify that at 8 seconds, x2 minus x1 should be equal to 120 meters. So if we verify this claim and we see that if that turns out to be true, then the graph that is given is exactly correct. Okay. So if it's correct, I can, no, let's first verify and then I can just draw a diagram and show you what do they really mean by a graph of path difference versus time. Right, so let's just verify. In order to verify, I have to do x2 minus x1. So x2 minus x1 is what? Is you have to find out, right? You have to get this as 120 meters. Now, let me write down the equations for x2. x2 is the equation that we had for the first term, which was what was that? x2 5t square, or okay, we can just write it as it was 200 plus 30t minus 5t square, whereas x1 was again 200 plus 15t minus 5t square, right? So I'll just substitute in this and find out what is the value of x2 minus x1. So x2 minus x1 would be x2 is 200 plus 30t minus 5t square. These are the equations that we had got when we substituted the given values, minus 200 plus 15t minus 5t square, right? So this will be 200 plus 30t minus 5t square. This becomes minus 200, minus into plus becomes minus 15t, minus into minus becomes plus 5t square. So here plus 200 minus 200 gets cancelled, minus 5t square plus t square gets cancelled. So you have 30t minus 15t, which is nothing but 15 into t. So this is the path difference equation. Now I know that stone 1 actually took about 8 seconds to reach the ground. So if I substitute that, I can find out the relative position. So at 8 seconds, stone 1 had reached ground. So if I substitute it here, I will know what was the position of stone 2. So x2 minus x1 is 15 into 8. And that ends you up with 120 meters, which is exactly what is given in the graph. So this means, or this implies, stone 2 was 120 meters away from stone 1, which was on the ground, right? Stone 1 was on the ground. Which was at rest actually, or rest, or let's say on the ground. Right? So that's what your graph claims actually, right? So this is what is given. So I'll just write a picture for you to understand it better. I'll just write a picture so that you understand it much better. So this is the cliff edge. This is ground level, right? So stone 1 was on the ground. This was the position of stone 1 at t is equal to 8 seconds. Whereas stone 2 was still, so this difference in path, it was about 120 meters at about t is equal to 8 seconds. So at t is equal to 8 seconds, it was still 120 meters away from stone 1 is what the graph is claiming, and the claim verifies with the mathematical expression that we have got. So this is given by the expression x2 minus x1 is equal to 15 into t, which is nothing but 120 meters. So this difference in path between stone 1 and stone 2 was 120 meters when the stone 1 had reached the ground already at 8 seconds. So after 8 seconds, you can even see the graph and understand what really happens. After 8 seconds, the motion of the motion of stone 2 is given by the quadratic equation that you already have. So you can just see what happens after 8 seconds. So after 8 seconds, you see, so it was at 120 meters at 8 seconds. The distance between stone 1 and stone 2 was 120 meters. You see the gradual after, at 8.1, 8.2, 8.5 seconds, 9th second, you can just see at 9th second, stone 1, the distance between stone 1 and stone 2 is reduced because stone 2 is approaching the ground. So it is at about 60 meters from the ground now. At 10 seconds, or let's say 9.5 seconds, the distance between stone 1 and stone 2 is about 30 or 20 meters from the ground. At 10 seconds, stone 2 has reached the ground, and you also see there is an extension. That means there is no further movement, because the question also says you have to assume that the stones do not bounce on reaching the ground. So you see that stone 2 is, the path difference remains the same. The path difference between 2 is 0. Between both the stones is 0 because both are at the same level now, that is the ground, right? So that's what happens. So if I have to show you those pictures, I can still show you. This is what happened at 8 second. At 9 second, this is at 9 seconds. Okay, this is the distance that is approaching the ground. 9.5 seconds, this is the position of the stone. The distance between stone 1 and stone 2 has further reduced. At 10 seconds, you see there is no distance between the two stones. The x2 minus x1 at 10 seconds is 0 because both are at the same level. And since the graph continues, it also says at 11 seconds, 12 seconds, etc. Also, the distance between both the stones is, the path difference between the stones is 0 because both are at ground level. When does that happen? From 10 seconds to 11, 12 seconds, both are at ground level, hence the path difference will be 0. Now this is how you solve and understand the problem. I hope you have understood it. Have a great time.